Hello everyone, welcome to day two of Azure Machine Learning Bootcamp. So this is brought to you by Azure Developer Community Tamil Nadu, and I am Vivek Raja, the speaker of today's session. So I hope so you all enjoyed the day one of the bootcamp. So I received a lot of feedback, very good ones. Thank you for your amazing and kind feedback. Today it's going to be more exciting than day one. So let's get started for it. So thanks for joining on a Sunday morning. So I really appreciate that you're taking some time to learn something new. And I can assure you that this is going to be one of your key steps for your data science career. So one such bootcamp was for me in my earlier days. I feel so and I hope so that this will be a game changer for you in your career. So today's session is going to be a little bit interesting and it's going to be really unique. The reason is that the what we are going to discuss, it's already available in internet, right? But what's going to make it much more special? In internet, or if you take Azure machine learning in particular, if you want to learn something, I guess you might have gone through some of the code samples by yourself. The one thing you might notice that it's always disconnected. For example, if you wanted to do a machine learning, you have a separate code for it, fine. But when you wanted to take it to a complete chain or a complete end-to-end stuff, you really can't find that. Or there is no continuity in the data or the data set they use or the methodology used. Everything changes in every single sample. But today, what I'm going to give you the best coding sample that you can ever get. It has an end-to-end flow with just one single data set, and it explains the entire concepts of Azure machine learning in one go. So that sounds interesting, right? So yesterday we saw a few things. Today we are going to continue on that. And if you're joining for the first time today, if you missed day one, don't worry. We are going to have a quick recap as well as the code samples which we are going to see. We are going to see it from the beginning again so that we are all on the same page. So once again, on behalf of Azure Developer Community Tamil Nadu, we all welcome you. And please do take some time to register yourself or sign up on our meetup page so you can get latest updates on the events which are happening. It's going to be both virtual events and offline events. So feel free to take some time to do that. And as you know, those who are attended day one who have turned up on day two, I can see very well that Karthik Raja is here, Arun Neelakandan is here, Prabhakaran is here, Ahmed is here. So happy to see the day one folks turning up for day two as well. So big hi, and the people who are turning up for the first time, uh, welcome you as well. We are proud to say that we are now 2,000 members strong. So it's a long journey and a very small. We have taken a lot of small steps to take up this particular milestone, and the credit goes entirely to you guys who have been constantly supporting us through the online events, offline events, and so on. So we have been running this from 2020, 21. So from COVID times, we have been able to keep up this membership as well as help you to learn Azure in a better way. And I hope so. We have serving as well as we have served the purpose. So if you are not yet joined our community, so we have our new handles available for LinkedIn and Twitter. So feel take some time to go and subscribe, follow our channels and our social media, so you can get latest updates on what we do. And if you find some time and you're interested, you can hop in anytime as well. So for folks who have been turning for the first time, so what we do, Azure Developer Community is we are a Azure based community. So we wanted to establish this platform for helping developers, experts, newbies, college students to get up to the pace of industry standards and also learn, upskill, and share with others. So the mantra which I always use is that three things when it comes to community. One is learn. You get to meet a lot of experts. You learn something, and the second important part is that you share what you learn. So whether you are a beginner or an expert, feel free to take some time to share what you have learned. It may be right, it may be wrong. So community a very safe space for you to grow yourself very, very much. And the third one is network. So you get a range of people over here. So from different demographies, different languages, different expertise, and people bring new skills or new contribution from each one's endpoint. So it's a very good way to connect with people and also be for it. So there is one common question that we get asked: Is this the community only for tech people? No. Uh, though Azure Developer Community is a technology and developer focused community, we do have a non-tech related stuff going on as well. So if you're from a non-tech background, from sales or marketing, and you still wanted to get onto Azure, there are a lot of ways to do it, and we from time to time do those meetups as well. So thank you everyone, and hello everyone. Good morning for joining in again. So and I guess we know you guys know what we do. We have host meetups, we have a good network, and for example, this bootcamp is a very solid start for your TP100 preparation. So you can consider this itself as a study jam. But if you wanted to establish a study jam where I could share you resources and we could connect on daily basis or on weekly basis for some doubt clearing sessions, we could organize that as well. And we reach out to colleges. We do a lot of college events as well as in-person and professional events. So stay tuned on that. So if you haven't joined us, so please take some time to scan this QR code and join our community. So we are 2,000 members strong. We host events, and we are very, very proud to say that we have been hosting continuously for 8 months uh, as an in-person event. So if you are in Chennai, we have hosted 8 months continuously. So and we are planning to host that in other cities as well. So with your support and if we know where you are coming from, we'll be able to host in your city as well. And always we'll be having a virtual meetups as an option, and we always try to do that as well. So the folks who have been also here, so I guess we received a couple of feedback on the attendance and everything. So those who missed day one, don't feel bad. So few people reached out that the form got closed before they made a submission. It's totally fine. Please do make a submission on the day two attendance, and we'll be able to process the same. So as you all know, like we are giving preference to the folks who have attended 2 days. But if you are attending only for day two, we could also consider it. We are planning for some surprise around that. So coming to the main thing, so it's an Azure machine learning bootcamp. So what makes this much more different? It's an end-to-end program for you to, if you are very new to machine learning, if you just know the basics of machine learning, you're going to take it from the basics to deployment and much more. So at the end of this bootcamp, or I could say at the end of today's bootcamp, you will be very much satisfied that you know you have learned something how to execute machine learning workflows in your cloud and how to productionize your models for your company or your organization, and also a lot of other features that you can leverage for making your workflows and productivity much more better. So that's the total outcome of this. And a little about me, what I do. So yesterday we skipped this part quite recently, and people were reaching out to me to and through the LinkedIn, and they were having a conversation after yesterday, so asking about what I do. So I'll just take some little bit of time to explain what I do. So I'm a VP of product in the startup. So I'm a founding member as well. So I prominently lead the product teams in my startup. So what we do is that we develop brain-computer interfacing. You might have heard about Neuralink, Elon Musk, right? So we are a direct competitor, you could say that. So we build devices that could monitor your brain signals, and that can control anything. So sounds interesting, right? So that's what I work in, and I am AWS machine learning hero. So machine learning is my favorite suite of technology. So I've been working that in several cloud domains as well. So I'm a machine learning hero, which is equivalent to the MVP program that we have in Microsoft, and also I'm a Guinness World Record holder. I've been 16 times multi-cloud certified with an expertise in focusing on AI. So I've been certified from Azure, Alibaba Cloud, Oracle, etc. And in my free time, during my college days, I used to attend a lot of hackathons. So I won around 20 plus hackathons here. So participated in over 70, 80 hackathons. Right now, I'm more into uh, judging and mentoring people who are going for hackathons. So if you have some hackathons in your mind and you want some help, please do reach out. I constantly write some blogs, not much nowadays, but I'll restart it. And I speak in a lot of communities and a lot of conferences. So keep a tab on my LinkedIn. You will get to know where I speak and what I speak. And again, so the folks who are new here, the folks who already turned for day one, you know how it's being done, right? So GitHub repo has all the information. So let me paste the GitHub repo, which has all the information about your feedback links, your attendance links, as well as all the contest link. Everything is updated as of now. So let me quickly paste that. in the chat. If you can scan it. If not, just click onto the link which I pasted in the chat. Uh, this leads to the complete overview of what we do in the bootcamp. So I can quickly walk you through on that. I hope you guys have registered and signed up for your meetup so that we could know that you are part of the community. If you missed day one, the recording is available in this link. Day two live stream is going on right now. And digital batches, it's up for grabs. And I'll soon let you know how you can get your own digital batch from Azure Developer Community. So these are the links if you want to follow our host and speaker. Feel free to do that. And we have the participation batch for people who have turned out for 2 days. We have closed the day one and the day two is open. We are reconsidering for the folks who have just turned for 1 day as well. So we will look into it, but do register, do sign up for 2 links. So the attendance and for your participation batch is also in the chat. And it's also available in your GitHub profile. So feel free to go up. And the social media contest is back for day two. So what you have to do is follow our social media links, which is our LinkedIn and our Twitter. Do subscribe to our YouTube channel if you are new here. So it's a brand new YouTube channel. So feel free to subscribe it, support us in that way, and do press the bell icon so you can get the notification. So coming back to the social media contest, you can post it in LinkedIn or Twitter or both. We will be picking out 2 winners from each social media, which is LinkedIn and Twitter, and it will be entirely based on how much likes and the shares that is received. So likes and shares is only what we consider. If it's in LinkedIn, it's called likes and repost. If it's in Twitter, we call it likes and retweets. So based on the cumulative account of each person of the likes and shares in each social media, you'll be giving that. And it's only eligible if you tag us, only if you tag us at Azure Developer Community TN. So in respect to social media, please do tag us, only then we'll be able to follow it. So I'm pasting the LinkedIn and Twitter links in the chat. So feel free to go through that as well. So this is our LinkedIn and this is our Twitter. Okay, so that's your first way to grab your batches, which is your social media. Second one is best knowledge share a batch. So follow our bootcamp and do take the notes of bootcamp. You can post the notes in your GitHub or your blogging website or in social media. Do share and tag us only based on you tag that us. We'll be able to go and track it, and we'll be giving the winner a day-wise winners for day one notes and day two notes. So that person will also get the badge. And yeah, we had a great attendance of nearly 50 participants for day one quiz. Day two quiz is also coming up. It might not be at the end, it might come in the between as well. So stay tuned for the quiz. And I will soon explain about the Capstone project and the Microsoft Learn Collection Champion. Both the badges are up for grabs. I'll do explain it towards the end of this session. So stay tuned for that. So, yep. So let me take a quick recap of what happened on day one. So especially for the folks who missed it, or for a best quick brush up for what happened. So we learned what is machine learning. We learned the basics of basic definitions of machine learning, like what is supervised learning, what is unsupervised learning, what is reinforcement learning, how it's being done, what are the different stages that we have in machine learning. Then we hopped on into Azure Machine Learning Service, where we understood why we need to have a well orchestrated machine learning service for you to execute that. We understood the challenges that we have in MLOps, so that we did it. And also, then we also understood what are the terminologies and architecture that we have in Azure Machine Learning. And then we brought up how you can connect your data sets to your Azure Machine Learning, how you can connect your blob storage or your how to create a data store, data asset, and how you can refer that in Azure Machine Learning. And we also learned how to train your machine learning models using scripts. So it's like a one command job that we did yesterday. In today's session, what we also going to do is I received a couple of feedbacks to take it slow on the coding aspect and to also explain the coding aspect in detail. Today's session, we are going to again go through the complete code, end-to-end code of taking one data set and then deploying that, training your machine learning model, deploying it, and also creating pipelines of that with just, and it will be all done in one single notebook and just one data set, which you can't really find that in any other samples and stuff. It is always a mess up of different data sets contributed by different people. So I'm going to make it much more easy for you. So we are just going to take one data set and we are going to take it from your training to deployment in one go. So stay tuned for that and we will take it off it. So what's the agenda for day two? We just have going to have three sections. One is how to deploy and how to streamline your machine learning workflows using pipelines. And we are going to go and explore something called automated machine learning. So please share some, yeah. Okay, so I'll do try to share your TP100 materials. What are the best ways to do it? I'll just give you orally, I'll say right now. If you wanted to get started with your TP100 preparation, this bootcamp is the first place where you have to head to. It covers most of the basics. The second step, at the end of today's session, I'm going to share something called Microsoft Learn Collection. That collection has the important details and the modules that you have to prepare for your TP100. That's your second step. And the third step is I'm going to give you a GitHub repo of all Azure machine learning samples where you can go and hands-on and try it. So that's a third way. I guess these three preparations should help you to get through your TP100. So we'll again discuss that at the end of the today's session. And Shanmugama, thanks for bringing that. And if I do forget it, please remind me in the chat about the TP100 preparation towards the end of today's session. So hi everyone, hi Chokolingam, hi Karthik, hi Vijay Bharati, hi Arun, everyone hi. So, and let's get started. So the section 5 of the bootcamp, which is the first, let's understand about what is model management. So yesterday, what we saw was after training your machine learning model, we were able to see a model asset in the model stack. So even Rahul pointed out that could you show us in the code wise as well as in the UI wise how the model is being represented as an asset in machine learning. We saw it. We'll see again it today. But now you have a machine learning model in your hand. Uh, Generally, don't forget everything about Azure machine learning, cloud, and everything. Now let's assume that you are working locally or you are working in a Jupyter notebook and you somehow trained a machine learning model for some data set. So now how do you test it? It's going to work well. Any answers? Yeah, uh, you validated using your test data set or validation data set. But how are you going to validate how it's going to perform in real world? Like if you're going to host a website, you host it first locally and see how it works, right? Correct. So have you ever hosted your machine learning models locally? I guess so. Not much answers. So I would take it as a no because probably most of the folks wouldn't have done that. So today, how we are going to do is how we are going to deploy your machine learning model to an endpoint. So here, how many of you are developers who have worked with REST APIs or APIs in general? Good. So a lot of folks have experience. So how does an API work? There's an URL, uniform resource locator. You send a request packet which should have some uh, fields in it, correct? So some JSON format of your request that you send it. Your request goes and hits some server or an endpoint. It processes it and sends you back some response. Now just connect back to your machine learning. So an inference is nothing but an endpoint, okay? And you send a set of requests. That request is nothing but you want your machine learning model to predict for that request, okay? The request should abide by the same data format that you use for training. So once you send the request, it's like a REST API, just a REST API. You send the data in a request in a request format. Your machine learning model now takes it, performs a prediction, and it returns a response of your predictions. So that's how an endpoint works, and that's how we need to deploy a machine learning. But what are the complications that we need to do? Like there is one thing. So how many of you have been using ChatGPT here or all your text? For example, translate services in Google or in your Instagram, see translation icon, or in tweets and everything. How many of you been using these sort of methodologies? ChatGPT, translation services. Yes, I see few folks are using it. Yep. So it's nothing but if you actually see those are all inference endpoints. So when you click for see translation or request for translate service, your text goes to your endpoint and it translates. Some machine learning model translates it and sends you back the response. And if you see ChatGPT, when you type and send S, right? And when you type and send S, some text, it returns back with a large text or some text generation, correct? So that is a very good example of inferencing. So probably to get more idea, let's just go and check how it works. So we'll get more idea. I'm going to ChatGPT. As you can know that I'm using ChatGPT very well. So even for the bootcamp content, whatever you see on the forms or in this one, it's generated from ChatGPT. But yeah, I'm sending that hello. Can you write a welcome message for Azure ML bootcamp? Okay, it gives me a text, correct here. So welcome to bootcamp. Let's make the future smarter together. I'm just pasting it for fun. Okay, so here is a like it's a proper example of inferencing. But if you say something, there is ChatGPT also offers you something where you could access is complete an API. If this is a GUI model, you can access it via API as well. So OpenAI, ChatGPT APIs are available. So that's an API model where you really send a request. So using Postman, curl, do whatever, you can send a request. Or from your Node.js application or any request response applications models. So now going back to our presentation. Oh, okay. So now we understood what is an endpoint, and we know what is the meaning of deploying that to an endpoint. Now let's understand what are the different types of endpoints that exist. What are the complications that occurs when you actually deploy a machine learning model? What are the considerations that you need to have? So how many of you here notice something very this one? So in ChatGPT, there is sometime a pop-up comes that the servers are at capacity. We couldn't process your request. How many of you have seen that? That we couldn't process your request. This one in ChatGPT. How many of you have seen that? Yes, I guess most of you who have used it would have seen that. The reason is that your endpoint runs in some server. So as you know that in servers, you know that it has a capacity to take in the request and do it, correct? So we also going to consider those aspects. So which compute you need to use to deploy your models and how it's going to influence your traffic. So all these aspects we are going to see today. That's going to make this deployment. And very well, we are going to, yeah, I've seen the rate limit error because of the quota. Exactly. So rate limit errors are a little bit different from the capacity errors because rate limit errors is that the OpenAI or whatever, whoever handles it, they won't allow you to send more than n number of requests in a short period of time. That's a rate limiting factor. But servers are at capacity is where you're free to send the request, but your server is so much loaded that it cannot handle that much of request. So that's the difference between rate limiting and your capacity, like server capacity. What are the two different types of online endpoints? So you can deploy that in local as well. So that's not a big deal. You can easily do it. But how you can do that online and how Azure Machine Learning Service is going to do it. So there are two ways to do it. One is managed online endpoints and one is Kubernetes online endpoints. So you might have seen in cloud, this particular word has been very well used, right? So something called managed. What is the meaning of managed? Managed is where you don't really need to care about the underlying infrastructure or what server it needs to use, whether it need to scale up, scale down. So those managed is where someone takes care of for you. So they are managing it for you. So one type of endpoints is where Azure machine learning takes care of your underlying infrastructure. So yeah, as Ketan said, yeah, the third party does your most of your work for you, and you just use it for your say. So it's like just checking in your hotel, right? So your hotel maintains your rooms, gives you all the requirements for you to just go and stay, enjoy your stay, and you have to just pay for it. That's exactly what happens. Just clear all link on the side. Okay, perfect. So the next one is Kubernetes. So Kubernetes is where, yeah, as Keetana and Arun said, yeah, Azure takes care of our instance and infrastructure. So there is a compute-based orchestration service called Kubernetes. It's a container-based orchestration service called Kubernetes. How many of you have heard about this name? Today, though we are not going to deep dive into Kubernetes today, we are not definitely not going to do that. But we are going to see how you can deploy it so that makes your online deployments much more efficient, and you can manage the necessary in this as well. So yeah, you have heard about Kubernetes. So we'll see about Kubernetes somewhere down the line in a different session. But today we are going to learn that you can also deploy that in Kubernetes. Okay. So what are the steps? So now we have understood what is the meaning of deploying a machine learning model into an endpoint, right? And we also understood that what it takes to become an online endpoint for you to deploy it and why it makes sense and what are the two different types of endpoints we had. Now the right way is to understand is that what are the different ways you can, what are the some terminologies that you need to understand to deploy it. So first one is to deploy a machine learning model, you need a model fundamentally, instinctively, and implicitly that is mentioned. So your model, it can be a model pickle file. So when you export a model, it can be a model pickle file. You can create a model asset using a model pickle file, or you can register your existing model. For example, yesterday, if you people have noticed, after our command job being executed, the model has been registered in models, right? You could directly take it from there, or we could manually register your model, or you can use your model pickle files locally, right? So first step is to create a model asset. And the second step is to create a scoring script. Any idea what is a scoring script? So the way how that endpoints works is that you get a request, right? You get a request of data to make your, and you ask your model to make a prediction, correct? To make that prediction, you need to process the data before sending that to your model. It needs to conform with the same data preparation strategies that you used while training, because that's where you need to do it. And the scoring script does, it loads the model and then sends the request and the requested data. The model computes the prediction and then it gives out the prediction result. So the scoring script consists of two parts. One is load and one is run. Okay, it's called init and run in your scoring script. So init loads your machine learning model. Run actually takes up the data, executes that in the model inference, and gives you the result. And environment is that since the model runs somewhere, it needs to execute somewhere, right? So it needs an environment. How many of you remember that yesterday we created something called environment and we added Chroma dependencies? So exactly, you can use the same dependencies here in the same environment, or you can create your inference environment also if you require. Yeah, evaluation, correct, as Rahul said. And your model should run on some compute, right? So you need to set some compute configuration. One is the compute instance and one is the scalability, so that it can handle the request. So which compute you want to use and how much you provision and how much it can scale based on the number of requests that is received. So these are the consideration that you take it to deploy a model. I guess that's fair enough. Now I'm going to ask one question. So we saw two types of endpoints, correct? Okay. Do we need to write scoring script because that needs to have an init function and a load function, correct? Do we need to write the scoring script for both the endpoints? Yes or no? do we need to write the scoring script? So model, you are bringing it, you manage the compute, you manage the environment. My question is, do you require to write scoring script for both managed endpoints as well as Kubernetes endpoints? Yes or no? Kitana says yes. Any other answers? I'm expecting a no. So Shanmugh Kumar also says yes, that you need to write scoring script for both. Rahul says yes. So we are going to find out today. Find out whether it's really required or not. So most of the folks say yes. Are we going to prove them wrong or it's going to be correct? Let's see that. So enough of talking. We understood that what is really meant to be a deployment. And now we are going to take back to the complete walkthrough. This is going to be a complete walkthrough from your beginning to your end. And from yesterday's code, based on the feedback which I received, I modified a lot, and I made the code also available public. You can find that in my GitHub repo. You know where to find my GitHub repo, correct? So that's my Vivek 0712 slash Azure Bootcamp, ML Bootcamp. So you don't need to open it and see because we are going to walk through by ourselves. So let's take from the very first step of how to create your data sets or how to authenticate your workspace and everything. I'll just quickly go through the Azure machine learning architecture stuff, and then I'll take you through how you need to authenticate your workspace, create a data set, access the data set, and then how to create a single job, a single script job that will train your machine learning model. And then after that, you'll be able to receive a model asset. So, do you know what's the next step for the deployment? Yeah, you take the model asset and you deploy it. We are going to deploy it as an endpoint, and we are going to access the endpoint and see how it, if it works or not. Okay, so let's take it very slow. I'm going to spend a little bit of more time in this demo. So feel free to enjoy it. No need to go and create anything by yourself. And this will brush up your complete walkthrough of what we're going to do today, or the entire bootcamp, I would say. The first step, where we have to go to your portal. So I'm going to zoom a little bit and go and create your own machine learning workspace, or if not, you can create it. Launch your studio. Once it launches, it looks something like this. What else we have? We have notebooks, we have automated machine learning, we have data. You know, data is where we upload or create a data set. We have jobs. So every single execution that takes place here, it's called a job. We'll soon see what is components and pipelines. That's our next topic. We know what is the environment. Is that you create an environment for your this one. So there are a lot of environments already available from Azure. You could use the same thing, or you could reuse it that as well. And models. Once a model is being trained, you can get the model assets over here. And endpoints. Once you deploy it, you will have an endpoint. Okay, so endpoint looks something like this. It has some URL, and you can just uh, access the URL, and it will give you that endpoint. I mean the predictions. So we're going to see today. Again, first step: go to your compute and create a compute on your own. Okay, it stopped. So let me restart it again. And it might take a little bit of a retime. Meanwhile, I'll just walk you through the code which is already available. I'm not going to run until the compute is up. You can see that it's not connected. So it's publicly open available. I made it available for you to folks to go and see how you can run these code by yourself. One request that I put you in the context of open source, that you are free to take this code and use it on your free will, because it's not, I'm not the complete author of that. I mean, the whole sources, but since I'm taking some efforts to populate it under one notebook, feel free to star the repo, fork the repo and use it so that it gives the right credit to the author. So not just me, if it goes to any other repos that you go for open source, keep that as your thumb rule to give credits to the right author, because that's the only thing that you can give back to the person who did the efforts for you. Follow us, and the first few steps which we already know. Authentication. So you have something called Workspace. You need to authenticate it, and then you connect your ML client to that from the configurations file. So I haven't showed that yesterday properly. I think I forgot to work on that. So on your workspace, if you go to your workspace and you go to your home, yep, I'll just show you the config file where you can download it. Mm, sorry, let me go back here. You can go to your workspace, and when you go to your workspace, before you launch or after you launch, you see something here called download config.json. So that has all your information about your subscriptions and everything. So feel free to do that. So that just download the file and keep it in the same repository that what you where you have your this one. So going back, let's see if the computer is up or not. It's running. So what you do, you go to your applications here, click Jupyter. Just for folks, are you able to properly follow and see the clarity of what we see here, like text-wise and everything? Are you able to follow? Is it too fast or too slow? Based on that, I'll adjust my speed. I think with no response, I would take it as an yes. Okay, thank you. Okay, so I'm going to take this notebook. I'm going to start the notebook. Let me close all those which is already open up. It's not necessary. So I might run a couple of cells here, but I might not run the entire stuff because few of the cells might take 10 to 15 minutes of time to run it. So first of all, authentication, where you have to have a managed identity, right? Yesterday we discussed about what are the different ways you can authenticate. What is the difference between a managed identity, service principal, a lot of stuff we saw. You can just go back to the previous recording or to the same slides. We have all the information. So I'm going to skip it. And from the config file, remember the config file we downloaded from the portal. Just keep it in the same directory, and then with the credential as well as the config file, just connect your ML client. The next step, what is connecting the data? So how you can connect the data set? Let's assume that you have your data in your some URL, some public URL. So this is a publicly available data set for your credit system. Okay, this is the same data set we are using it. Now you wanted to load that data set in your uh, create a data store and asset. So what you do is you create a web path, you paste it, and you create a class called data and give some names on that. So now it already has bootcamp credit data. I'm just going to rerun it. It's not going to do any harm for me. And the type is called UID file. So yesterday, if you noticed, we saw about the different types of data assets. So one is URI file, folder, and table, correct? ML table. So these are the three data types, asset types. So it's a file which we are going to upload. So it's a file. Give some description, tags, and versions. It's up to you. Let me run it again. So now let's go and see where the data is up and available. So where do you go and see it? So you go to your data, and we created the data under where? Sorry, sorry, I didn't still register it. Sorry, let me register it. Yeah. So again, I'm running the next credit data. Your data set with credit, bootcamp credit data were registered to the workspace. The data version is something 0.1111, 1.00, whatever. So, which is the latest bootcamp credit data, which we did it. So it's available as a data asset. You can now explore it. You can use it in jobs and everything. So who did it? So I did it in early morning. So I know that 6:30 a.m. is a very early morning. But yeah, I was revamping the whole demo based on this. So now we know, now we know that how you can add your data set to your workspace and where you can find it, correct? So now the next job is to create an environment. An environment is what is that? For example, if you run a Python program in your local, you need to install some dependencies, some libraries around it, correct? So this environment or this model is going to run in some container somewhere in some virtual machine. You really don't know where it's going to run, correct? Azure manages it for you. But to run that model in that particular platform, you need to supply the environment or the dependent libraries that you that make sure that the model runs on it. So we need to create a dependency file called a YAML file that these are going to be a conda dependencies. Conda is a framework. I'm creating a dependencies folder and I'm just adding this dependencies to the conda.yaml file. These are the dependencies which I wanted. Now what I'm going to do is I'm going to create an environment out of this particular dependencies. So I'm going to create an environment class. I'm going to give a name for it, description, tags, and yeah, the conda file. This is what is important. The conda file should point to the YAML file which we created. Okay. And where that conda file needs to be registered, it should be registered on top of an Ubuntu 20 system. So that's an image of your container because for folks who are familiar with container and stuff, you might follow it. If not, just leave that. Where do we need to put the JSON file? Just put it over here, folks. So I'm just keeping it in config. Just keep it in the same directory. That should work. Yeah, or anywhere you keep it, just refer that path correctly. That should be enough. So from config file is there right here. So yeah, just give the right path to it. That's it. That's more than enough. So going to the environment, I'm going to run it. So the main this environment is going to be created with this image, and this image is going to be installed in your compute. How do we get the details of the images? So there are a lot of publicly available Azure images available. So you can go and see the compute VM images available. So you can pick out one of the images which you prefer and you can do it. So just Google it and you'll be able to find the images that you have in the this one. You yourself can create an image and also do it. Oh, not this one, I guess. Not. Yeah, this is an image. You can create your own image, and Azure itself provides a lot of predefined images. For example, for Ubuntu or and so on so. So now we are going to create an environment and register it to our workspace. Run this. The environment with this bootcamp is registered. So let's go and see whether it's being registered or not. Where do you go and see it? Environments. We created an environment name called Bootcamp. It should be there. Oh, okay, it's in the same image, I guess. So yeah, sorry. Yeah, this is where Rahul. This is where you can find your own images if you want to. You can just directly use it. So these are the images which is available. The custom environment which we created. The Bootcamp credit EVMB. So this is what we created right now. So this is available in our custom environment. Or if you want, you can just go ahead and directly run your curated environments is already available. For example, if you're working in deep learning, you can just go ahead and use this Azure AutoML DNN version or which supports PyTorch or which supports TensorFlow or SDKs alone and so on. So use which image works best for you. All right, so now we understood how to authenticate your workspace, how to bring your data to the workspace, and how to create an environment on top of it. Now comes the fourth step, how to create a training script. So I'm just creating a folder and I'm going to write this whole file inside in the name called main.py. Okay. Details of it is a conventional way how you do machine learning, but just walk through. So I'm just passing the test data set link. I'm passing the test train ratio. So the split ratio. Estimators and learning rate are the parameters that you can pass for the machine learning model, which I'm going to use it. And what is the model registered model's name? You can log the details of your each and every run. For example, yesterday we saw the analogy about chemistry labs and how it's very much related to the experiments what you do here. So in each and every run which you do in your chemistry lab, you record your findings in some way, right? So you note it down in your notebook If it's in your school or college, you get that signed by your examiner or your lab assistant or someone, right? So you need to log and keep what's happening in a one particular run. If it's not up to the mark, you redo the experiment and you still log the results. So the ML flow also supports the logging where it will log all whatever details you want to log. So when I say the log metric and I send some key value and some key and value pair, it will log and keep it. So log metric is one way to log the details. So I'm taking the input data and preparing it and splitting the data into training and test data set based on the test train ratio, what we send. Next is training the data set. The reason why I'm going step by step for this particular training the model is that we are going to see how it's going to be much more efficient when we use pipelines, okay? Azure machine learning pipelines. So just give a little bit of importance or attention to this particular code right now. Not the details of it, but how we write it. So preparation we have written. The next is training. The training is that we need to create a X train, Y train, X test and Y test. That's a conventional way of doing machine learning, right? And then you pick a machine learning model and you train on it and you fit and train on it. So I'm passing one of the hyperparameters as n underscore estimators. Learning rate I have passed from the arguments. And then I'm fitting the X train, Y train. And I'm going to test and see how my prediction works. Okay, I'm going to give my test data and see the prediction. And I'm going to print the class. Print does not work. It does not make sense if you use print statements here because it's running as a script. It's going to run somewhere else, which you can't see. So you have this string. This is ignored. So you don't really need to have this print statement. The next one is the how you need to save and register the model. That's the important part. Now, we know that we have trained the model, but how are you going to register this model in our workspace? How are we going to do it? So the ML flow still helps us in that. So with the log model, the model name is CLF, right? This is where we create the CLF. You're going to log that model, and I'm going to give a name for that model, and what is the path of that model. Okay, that's a name of the model. And I'm going to save the model using the model save underscore model function, which is available in your what is the use case of this model? Okay, so what is the use case? First, okay, then let me take you through the data set properly. We could explain what is it's doing there. That will be also helpful. Yeah, I'll just show you here. So the purpose of this machine learning model or the data set here is that we are going to see, where is it? So this is a credit data set. We are going to find if a person, so okay, it's just there, don't worry. So I'll just explain what the credit data set does. So the credit data set is that we're going to predict whether a person is going to pay or fail a particular credit card bill. Okay, that's the whole point of this data set. So it comes with the default information about the payments, what is the demographic factors, how was the history of payment done by the person and everything. So these are the details like pay zero, pay one is that each and every amount and everything. Whether he's going to pay for the next month or not. So when it comes to credit card, yeah, it's not a credit card fraud detection. It's we can say it is a not a fraudulent transaction. It's a we are going to predict whether the person is going to pay the next payment or not based on your history of payments. Okay, so that's a use case or that's a this one. So it's a classification model. At the end of the day, you're going to say whether the person is going to say yes or say no, whether the person is going to pay the amount or not pay the amount. That's a prediction we are going to do. And coming back to the model, so that's a use case. It's a classification model. You can use any classification that you want. By the default sample, we are just using gradient boosting classifier. You can use logistic regression problem model. So any model that satisfies your classification, this one. And it's much more better if you take a model which is a binary classification model. So because we are going to just predict yes or no. Yeah, Rahul said it, yes, it's a classification problem. So now I guess you understood what's a use case that we are going to do because This is also going to help us in our next section, automation learning, automated machine learning. Okay. So after that, I'm going to save the model. The model is registered, and I'm going to end my logging and done. So let me rewrite the main file. And then what I'm going to do is I'm going to run the command job. So command job is where you take a command, and command job is where you run a script, one particular script. It's just a one single standalone script running part. So what are the inputs it has? The inputs we have is a data, and the data's input is a URI, and the path is a credit data path. The credit data path is what we created and registered over here, right? We had a credit data, it gives you the data, and dot path gives you the URI of that particular thing. Okay. And I'm going to pass the parameters of the input. So if you remember here correctly, what are the arguments that we are going to pass? Data, test train, in estimators, learning rate, registered model name. So this one, test data, I haven't passed the in estimators, but it already has a default value here. So default is 100. So even if I don't pass it, it will still run. And the register model is a model name, which I'm going to give that as a credits default model. It might take a little bit of time to train, so I'm not going to run the cell right now. So let's just assume that it runs perfectly, and it ran perfectly. I can assure you that we are going to just see it. Yeah, is hyperparameter tuning recommended here, or should we do before we build the pipeline? We haven't still entered the pipeline phase. We haven't still created the pipeline, but good that you brought this question. Hyperparameting is where you first train your job and then you see whether the results are up. You can create a hyperparameter job as well. So this is a training job, right? Where you train a data set. There is a job available for hyperparameter tuning, but since it's a beginner level class today, I didn't actually keep that hyperparameter tuning job in today's section, or at least in today's notebook. But I will append the link to how you can start your hyperparameter tuning in the same notebook as well. So I'll do it in the GitHub repo. Thanks for bringing it up. So it runs. So once your model is run, it's going to get registered in your Azure Machine Learning. Let's just see whether it got registered or not. Yes. So it is an ML flow model. It got registered. So what is the experiment name that we have given here? The experiment name is Bootcamp EXP underscore credits, and it's going to use the Bootcamp credit ENV at the latest. And the display name is called credit default protection. So let's go and find out what all these terms actually mean. The model list has Bootcamp underscore ESP underscore credits, which I ran today morning. And if you go and see, the name of the model is credits defaults model, and it's located in some asset ID. So you could go ahead and deploy it right away, right now with this deploy, but I'm also going to show you the programmatic way of doing it. Okay, you can create an endpoint right away if you want to do that. But let's go and do it in the code wise because it's just one click away. Now comes the important part of how you need to deploy that as an online endpoint. I'm going to create some endpoint name, which is called something like this. And this cell actually takes a lot of time, so I'm not going to run it, but I've already ran it before today's session, so we could go ahead and just see how the results are. So we are going to use a managed endpoint. So managed endpoint is where your Azure takes care of your all your information. How are transformations like scaling and one-hot coding taken care of? Good question. So this is script file. It's not that it's a predefined file that generated. So you should be part of it. Should be part of the preparation, and you could append all these preparation transformations like scaling, one-hot encoding. You can do it. We haven't done the scaling part and stuff, and one-hot encoding. It's not necessary. I'll tell you why. Now start. One second. Just let me open the data set and show you it's opening. Wait, so that you will get an idea. It's a numerical data. I think there is no string data available in this one, so no one-hot encoding is taken care here. We will see about this feature engineering part a little bit later. The reason why I'm not been emphasizing is that there's the reason for it. We are going to see how you can take care of your feature engineering without you yourself doing it. So your automated machine learning will take care of it. But yeah, uh, again, the pipeline, we right now understand it, Rahul, we are not running this as a pipeline, we are running this as a single standalone job. So it's not a complete pipeline. So all your training, pre-processing, everything takes place in one single go. And the pipelines is where we are going to separate the pre-processing, we are going to separate the training and everything individually and run it as a different step. So that's our ultimate goal of pipeline. Let's quickly come back to that as well. So Ashish, if you want to do more pre-processing, just include your data, your preparation terminologies, like your methodologies here. That should do. But here today, no, I'm not doing that. So coming to the managed online endpoint, what is the case of managed online end deployment? It takes care of the compute. It takes care of the infrastructure of the scaling and everything. And I have asked one question in the beginning of this bootcamp or through when we were discussing about this managed endpoint. Does it require a scoring script? Scoring script is where you need to load the model and then write the necessary functionalities where you need to communicate to the model to get the result and then send it back to the as a response. That is the purpose of a scoring script. But have we written any scoring script here? The answer is no. In the managed online endpoint, it's not necessary for you to write a scoring script. Azure takes care of itself. Just ping it to your endpoint, and then it should do the business. But for the Kubernetes endpoint, it is necessary for you to write the scoring script along with the key. You need to write it. So that is a difference that you can keep in mind while you're doing it. I'm going to create a deploy pipeline, and this is a sample request. Okay, I'm sending some request for this, and these are the data which I'm sending. Okay, so we have two data points. One is this one, and another is this one. We are going to check whether the person is going to pay or not. Right now, the endpoint is already deployed, so I think I can just directly run it. It should work. Okay, I just need to run the names. And I'm going to take, okay, I just slightly skipped a couple of lines, so let me go one by one. I'm going to register this endpoint and then takes time. Endpoint is equal to, let me go and take the same endpoint that is already being deployed because so that we could test and see how it works. Right. So this is the endpoint name. I'm just going to take it. If not, you can just use the same endpoint available. So name is equal to online endpoint name. Uh, let's see if this works. Okay, it's not available right now. So, but anyway, your endpoint is already deployed, right? So it should we could be able to pass the request if it's already available. Uh, yeah, I just need to keep the endpoint name over here. So that should do, I guess. Okay. Nothing much is not big sort of error. I need to create a directly before writing it. Simple errors. Yeah, now it works. So this answer comes from your deployment of this particular endpoint. Yeah, now let's roll back a little bit and see how what all the steps we have done here. So the first thing is you're creating a managed endpoint and you're giving that a name and you're going to register that to your here. So once that is done, you'll be able to see here. Okay, so you're going to see that here as an endpoint. Just go to the endpoints, you'll be able to see the same name here. It's an online endpoint which I created today. So you can know that it actually works. So it's not old ones or something. Okay, so what you did, you sent two data to that, and since it's all numerical value, now you could have understood that one hot encoding was not required for this. So it gave the predictions as 1 and 0. So the first person is going to pay the payment, the second person is not going to pay the payment. So your things have been here. But now let's see how this prediction or how the training also went in, because before we go into deployment, I just also wanted to show you that how the model was trained and what are the accuracy of the model that we logged, because I slightly skipped it. Okay. So when you go here and when you click on the model, we could see what all different has. So model.json file is here. Let me quickly check artifacts. Yeah. So this is a model which was actually run once. So we can see the endpoint which was deployed for this. It is connected. This model is deployed on this endpoint. And what all jobs which were run, we could see that we ran only one thing. And here is what we logged in that. Remember, we have something called ML flow or logging. So it logged a lot of details, which is like what is a YAML file, what is the serialization, what is a model environment, and everything. It logged over here. So let's go and see the jobs. That's where that particular job was executed. So if you go here and see the recent one where it ran, what? Okay, this is a auto ML. Sorry. Okay, this is a pipeline. But yeah, let me check the other one. This is yesterday's, which didn't run. Mm, yeah, the prediction one. So this is where the model actually got executed. Now let's see what were the parameters were used and what were the metrics that we were able to log. We could see that what are the metrics which we were logged. We had 23 features. If you remember correctly, we had gone and logged something called num samples, num features, which is exactly being logged here. Num features and num samples. What was the training accuracy score? 0.83, 83%. F1 score, training log loss, and everything. So we could understand what was the accuracy of this. So now let's just go back again to the original stuff where we were able to deploy. Now we were able to access the deployment as well. So we were able to send a request and we were able to get this one. Where can we see the logs? Yeah, Rahul, it's where how you see is go to the jobs where the job was executed, because it's a command line job, right? And you are given a name for your command job. Remember? So you are given a name for your command job, a display name here. So just go to this particular job and you will be able to find the details and the logs of it. So the jobs, I'm just going to this, and there are multiple jobs which are executed. I'm going to the job, and the job name is credit default prediction, which is the same job name that we used. And here, if you go and see the metrics, you have all the metrics and charts which will be available, and the images, which is we didn't use any like image for this one. If there are multiple child jobs, according to this, we'll also will be able to see that. So all this monitoring, everything we can do. So metrics is where you go and check over here. So your accuracy and everything is listed. And this is how you deploy it to your online endpoint. And second comes is your Kubernetes endpoint. Today we are not going to see that, but it has the same methodology how you do it. Only thing is you need to add a scoring script. I've appended the link to for you to go and learn how Kubernetes deployment works. So it's up to you. Now comes the pipelines. So before going to the pipeline, let's just understand what is the reasoning behind it. So jobs, no, Rahul, jobs are different from experiments. An experiment might have several jobs, right? So how the functionality works, let me go back to our old jobs comes under the, okay, can we have a visualization of how the training went? Visualization in the sense how the model training was going on. Uh, by visualization, what do you refer to? You mean the metrics and scores, right? That is what we already got it. But what do you expect on the visualization part? So coming here, workspace, yeah, experiments. Under the experiment, every time you run something, it's called a job. Okay. Yeah, see, Amit, if you actually see what is the difference between your Jupyter Notebook and script is that your script runs somewhere in some container. This is a production sort of a way of doing it. If you want to do experiment and see, run it in a notebook. So that is a difference that we saw yesterday as well. So when you need to opt for your notebooks, when you need to opt for your when you need to offer your notebooks, when you need to offer your scripts. Your experimentation is where you need to have a interactive and visual environment where you want to do see the training and loss graph, or you wanted to see the outliers, you want to see print and see. That's where you need to use your notebooks. But if you wanted to train in a production, what is the difference between training in a production is that imagine you have thousand, you're working in a big organization with 100 machine learning engineers, and daily you train a model for evaluation. So big models. So you can't run it in your notebooks. It gets needs to get executed in some compute which is available somewhere else in your organization. Correct. So to train over there, that's where you need to use your scripts, and your scripts runs in some container. So you should not have any interactive or visual because it does not make sense. And yeah, what is a one ultimate goal is that its scripts are ideal for testing and automation. Okay, so remove all your non-essential code, which includes your visual, all your print statements and everything. And yeah, Rahul says you can run the endpoint on a JSON file. How can we run on a okay, so okay, this is where do we need to that's a good question. So again, let me come back to the request and accessing point over here. Okay, your managed endpoint takes up JSON as a double string. But if you write your own scoring script, this is a request, right? So with request, you can actually send it in terms of different applications context file. So you can send your file as a complete context as well. So we have different application slash context, right? So you can send file also as a request, but in your scoring script, make sure that you write the in the run method, you write relevant code to import that, read that data, and then send it to your machine learning model, right? That's how we do the inference, right? So before sending it, make sure your request and your file context are matching equivalently, so that you can also send files that I've done for Kubernetes. For online managed service, I haven't done it myself. I can verify and tell you that as well. But servers, I have sent a complete CSV files for bulk predictions. I hope so that answered. Will you be providing? Yeah, it's already appended to the link over here. So you can find the what's it? You can find the links to this notebook in my GitHub repo, and you can just go through by yourself. So hardly it is quite very simple. You have all the necessary scoring scripts. It's like it's just a couple of lines. I can just show you if you wanted to scale the deployment, test screen. Where is the scoring script? Okay, they have used the scoring script over here. So score.py double underscore model. You can take a look at it at your leisure time. So let's not this one. So in Jupyter Notebook, the only way to register your models, please, any other language or workflows there. Not required. So how we are actually now sticking to Python SDK. What are the different ways you can do it? Just go to your portal, go to model. You can register it from your local file directly. If you have a pickle file in your this one, you can do it. Or if you already ran some outputs and you can need to get it out of the job output, also you can do it, which we'll also see in this one. Either you can do it programmatically, you can do it in CLI. CLI is also available, or you can just use a GUI as well. It's not that Jupyter Notebook is a thing. We are using Python SDK, and Jupyter Notebook is a way to execute it. So it's not a call to Jupyter Notebook. Okay, I think that answered your question. Now let's go to the important aspect about pipelines. How are we going to receive the batches? So, Mayank, we'll get back to it at the end of the session. But just giving you a brief answer, you will be able to receive that over your email. So if you have filled the forms correctly and if you are eligible to get a badge, you will receive the badge in your email and it will also be displayed. So I'll show you that at the end of the session. Don't worry, it will be sent directly to your email. You don't have to do anything else from your end. Oh, sorry, I'm just skipping a lot of things at the beginning. Okay, now comes the important part of Azure machine learning. So, uh, pipelines. So there are a few questions which were very relevant to today's session. Is that what did you do about your data preparation? Why you didn't concentrate on that, or why you are executing that as a one single job? Why it's not executed as a process pipeline? So we had a lot of questions back and forth, right? So the answer for this is pipelines. The pipeline is to streamline your complete machine learning workflows. And for example, let's assume you wanted to rerun a couple of steps multiple times. You want to redo the steps multiple times. Azure machine learning pipelines helps you to just do it with one single. You can just recurrently do that. You can schedule your pipelines as well when it needs to get executed. So these are some advantages that comes to come. So I guess I briefly explained it. Let me just walk you through that info as well. So Azure Machine Learning Pipeline is an independently executable workflow that has a couple of steps or components. So each a pipeline is where you run a lot of steps, and if you ran all the steps, then your pipeline has been executed completely. Very simple analysis. It is very common terminology. Where and what your Azure machine learning pipeline should focus. Entirely, implicitly, we know that it's only meant or it's primarily meant for your production, but it's much useful for your experimentation as well. So the reason is that let's come back to the reason a little bit late, but what are your pipelines should consist of? So you could separate out your machine learning workflows into different domains so that it can be like data preparation can be one thing. Your training configuration, you can configure it and send parameters to your pipelines. You can train and validate it efficiently. I, you can rerun one single step in a pipeline multiple times also. And the reason why I told that it's also much more easy or good for your development phase because you could share your pipelines, so you can reuse your pipelines with your fellow data scientists. You can share across your pipelines as well. So if they have your pipeline endpoint, they can run it from their end as well. So it's possible. So what are the key advantages? Once you set it, your steps, once you schedule it, it runs automatically on itself. You could define different compute for each step of your pipeline. For example, your data preparation might not require you a big compute. You can assign one smaller compute for your data preparation. And for your compute for your training instance, you can allocate a large instance. And again, for your inference, you can give a moderate instance. But if you take this the command job script, we included everything in one single go, right? And we included all your data preparation training in one single code, which means your preparation of your data also uses a big chunk of, or it blocks your big instance, which is much more useful for your training. So we can now split your data workflows and you can assign functionalities for each step and you can assign different compute for each step as well. So yeah, going back to prepare and reusability, you can share your pipelines from REST API. You can trigger pipelines using REST APIs. We might not use it today, but I'll just show you how pipeline runs. And tracking and versions, you can create multiple versions of your pipeline and you can manage your scripts and data very separately. And each and every steps can be easily maintained and gives you big modularity. Instead of having everything under one script, we have separated out the scripts and we have managed it properly. Even now, you might ask a question. So, Vivek, you are telling that pipelines give you modularity, but you are telling that in your script job where you went, we included everything in one single script. What if I just take the necessary part? For example, data preparation is a separate command job. Training job is a separate command job. If I do it, I'll be able to do that as same as pipelines, right? You are partially correct. You can do that, but who's going to manage the separate steps? Or how can you link that after the step of this data preparation, this results must be passed to your next step or your next command job for user. So for all those integrations and everything, pipelines are much more usable. You can take your results from your previous job, previous steps, and can easily integrate that to your pipeline. So there are a lot of features around this. So that's why we recommend you to go to pipeline. You could establish your own pipeline by yourself, but since one has already done it for you, why take the hardship? And there are different types of pipelines. We'll see that. We know that in a pipeline, each executable thing is called a step. It's called also component or a step. And there are different steps. So Python script step, we have command job. Command job is also one step. We have estimator step, auto ML step, data transfer step. We're not going to see everything. But these are different steps that you can go and explore and you can find it around that. Is this pipeline aligned with DevSecOps? Yes, you can actually secure your pipeline with keys since a REST API, and you can secure your pipeline with keys. Uh, that's the security aspect. You can actually assets are only managed within the pipelines domain. It's not available everywhere. You can restrict the accesses also, and also how is it aligned with the DevSecOps? So in any operations, if you take pipeline as a sequence of steps. So DevOps is your sequence of steps for your deployments for your web application or any application. This is for your machine learning. Other than that, I guess it's entirely the same. Scheduling a pipeline, you can use something called schedule recurrence to schedule your pipeline, and you can re-trigger it as well. So uh, that you can do. Now let's just go and see the demo of it. So I didn't include the demo slide, but we have a demo for that. Very quick, we are going to go through this very quickly. So we now know how to deploy. Let's go and create your pipelines. The first thing is you need to separate out the steps. You can define your own steps. I'm going to develop each component in a different way so that you can get to know what are the different ways to create a step. One, we'll do it programmatically. So one is I'm going to keep the data preparation here. So data preparation is here. I'm not going to run the code, but it's already being executed. I'll show the results at the end because this also takes a little bit of time. I'm going to separate out a script only for data preparation. So where I'm passing the arguments, I'm logging it, and I'm just mounting the output parts as well. So that this output part can be an input part for your next step also. So you can add more data preparation methodologies over here. And then what I'm doing is I'm creating a command job for this data command. So name is data prep and data preparation. Someone also asked about the visualization of execution, right? You can visualize the execution of it, but not the inner details. We'll see that as well. So description, it takes a input file and it creates test train data set. These are the inputs. We have data input and the train. Output is that, remember, we are setting some outputs to it. So output, yes. So output part also we are actually setting. So so that we could use it for the next steps as well. So it will be in read write mount, so we can use that. Where is it? Yeah. Log metrics, train test data set, and the output parts are mounted as a folder. So it goes and outputs at the test and train data path. So the outputs are mounted, and we are going to pass the environment and the code. Similarly, how we do it. So now your data preparation component is done. Now let's create a training component. So we have programmatically done the values and how we need to schedule your command. So let's do that for your training as well. So training, I'm going to select the file from the outputs folder. From the outputs folder, I'm taking the train and test data and mounting it and then doing the training part. So how we did it exactly a bit previously. And then it creates your classification report, you register your model, same as what we did earlier. But I'm going to write this file as a YAML file, which is like if you feel that you are very excellent and you prefer writing in YAML file when it comes to pipeline, you can do it. Type command, if you different types of jobs, you can write command, all your data, explorer pipelines, paths and everything. Inputs, train data, test data, learning rate, all your input commands. Output command is a model of URI folder type. Code environment, we are setting up what is the environment of this, and also the test data, everything, all the commands of how we need to execute it. So you can write it as a YAML file and you can load the component, you can execute the component as you usually execute it. Now we have two methodologies, which is data preparation and data model training. So we need to build a pipeline out of this. So let's see how we can create a pipeline of this one. So I'm going to create a create defaults pipeline, and what is the name of it, and so on. So these are some this one. So I'm going to first take the data preparation job, and I'm creating a component of it. Then I'm creating a train job, the component of it, and then I'm returning that. These are the pipeline. This one. So it's going to return that. So this function is just going to take all these inputs and just return a JSON of some key and value pass. That's it. Okay. So now I'm going to take this, I'm going to take a register model. I'm going to create a pipeline out of this, and the result is a pipeline uh, configuration. Once a pipeline is generated, so this configuration is required for you to submit it. The pipeline job I'm going to create, I'm going to pass this pipeline and I'm going to name the experiment as, I just kept it as E2E registered components, which was a sample. But if you just go and see here to our, where, where we could see it. So if you see the pipelines, we have created one credits default pipeline, which is our pipeline. And if you see here, now it gives you beautifully how the pipeline was stepped up. So we added data preparation for training was there. It gives you data train and data test. The data train is passed to this, and your test data is also passed to this, and your outputs also, model output is given out here as well. So these two are now created a pipeline. So you can resubmit it, you can publish this pipeline, you can use it across your this as well. So this is a way how you can visualize your how your pipelines work. And when it comes to jobs, you can see underlining jobs how it went. So each job you can actually see it same wise. And these are child jobs, which we would say. So this is how you run a machine learning pipeline, and that gives you a overall understanding about what is yeah, I think Adesh, welcome. But yeah, you joined a little bit late. We completed two sections, but anyway, thanks for joining even after this. So, but anyway, I'll just quickly summarize what we did today. We went line by line on what is the use case that we are going to implement, how we are going to authenticate. We connected the workspace, we connected the data to the workspace, we created an environment, and then we created a training script and ran a command job. We saw that till yesterday. We also revised it today. Then we saw about how to deploy that to an online endpoint with a couple of code. We deployed it to the managed endpoint. And then also what we did, we understood what is the meaning of pipelines and why pipelines is required. We created two components and then made that as a pipeline and submitted the job, and we could able to see the results of that. So these all those code samples and slide decks are available, and you have this recording always available as well. So others you can come back and visit the best portion of it. And for folks, I'm just reminding it again for folks who are present here. Please submit your attendance. Only on basis of that, we'll be able to grant your attendance this one. So if you haven't still done, please do it. I'm repasting it again. So now let's go back to our presentation. We now saw what is the pipeline. Now comes something called automated machine learning. So as a data scientist, what we did, we took the data preparation was done, we collected the data, then we are supposed to do feature engineering and everything, and then we need to select the right model. If you remember, we just didn't opt much for your data preparation and model selection. We just went with one. But what if I wanted to select the best model? I wanted to apply the best data feature in feature engineering methodologies, but I don't want to do it. I want my service to figure out by itself what is the best way to do that. So automated machine learning is where it's nothing but they have written a bunch of pipelines that could re-execute and find which is the best hyperparameter tuning, which is the best model, and how you can prepare your data in a better way. And the best part is it does not involve any coding. So from your end-to-end part of from your machine learning, which is your data collection and processing, all your transformation, cleaning the data, training the data and selecting the right model, hyperparameter tuning, and then validating on the test and train data sets, and then deploying it. You could just do it with a couple of clicks. That's what we're going to see right now, how you can relate data. So before that, to understand what is automated machine learning, these are mostly for people who are non-pro data scientists, who are much more from the non-tech background, but turned out to be a data scientist later. So for them, it's much more efficient for them to use it. So how a data ML process works. You have a feature selection. It will understand these are the best features. It itself runs a lot of models by itself and selects the best model. It does the hyperparameter tuning of the best model and gives you the result. You can just deploy it. So just coming back again, it does the feature selection and all those data preparation. It runs the several models parallelly, several pipelines parallelly, and it selects the best model. And within the best model, it does hyperparameter tuning to give the best result, and then it gives you the best model as your output. So imagine these were the stuff which you are trying to do in a very complex manner. If a service can do it for you, that's automated machine learning. So automated feature engineering, it can do time series forecast also. It gives you the results in a report format, so you can see why it made these predictions. So let's quickly see the demo. It's not going to take much time. I'm going to AutoML. I've already created a job, but let's see how to create a job first before seeing the results. Here, the data asset is available, or else you can just create it on your own, but we already have the data set available. I'm just not creating it again and again. I'm selecting this particular data set. I'm going to configure the job, which is quite important. You can pay some attention to it. Let's keep some name for this particular experiment. For example, if you want to keep it as AutoML, and you need to specify what is the target column. So target column is Y. I'm selecting it, and where you want to run the this pipeline. I'm going to run that in my cluster dev-cluster. It automatically identifies that it is a classification problem, but if it's not able to, you can select which problem you want to run. It supports classification, regression, time series forecasting, computer vision as well. So it's a classification problem. Let's go for it. Now comes a validation and test. So there are different ways to do your validation, K-fold validation, train validation split. You can do it however you want. You can do a split of train and test data set. And if you have a separate test data set, you can upload that as well if you want to. And then finish will actually run your job. Okay, let's not do it. It's expensive as well. And also I already run it. It takes a lot of time. I'm going to automate a machine learning and I'm going to show the results of it. So once it is completed, it has ran several models. These were the number of models which it ran actually. Each pipeline job represents a different model. It evaluated a lot of models, like these many models it has evaluated, and it came up with a complete report that which gave the best results. What was the AUC, area under the curve? And voting ensemble gave us the best results. We can view the other metrics as well. The accuracy was 0.82, the AUC is 0.73, and F1 score and so on. So now let's just go and compare that with our existing metrics, what we got. Your training metrics. So accuracy is 0.82 and so on. So let's just go and see what was our accuracy back there. I'll go to that first. Okay, this pipeline, sorry. So the training accuracy was 0.83. So we were able to do it with our model, but imagine you are able to explore tens and 20 different types of model and it can do a lot of stuff. So it's a very simple data set. So we could understand it gives you sort of a strain. And training, you as well know that training does not reflect the actual accuracy because it could go either wise. So AutoML, when is the right time for you to execute? If you don't have much time and you want to explore a huge horizon of models, that's where you go for AutoML. And before you push it to production, reevaluate your models to make sure that it's the best before you go for it. So that brings up most of our learnings together. What all we actually did was we were able to take it from the very beginning. What is machine learning? What is we learned the basic concept of machine learning. We went to Azure Machine Learning. We created an account. We created a workspace. We explored what all was there in Azure Machine Learning, and then we ran single script jobs. Then we went on to deploy that single script jobs models. We know how to register the model. We know how to register the data, how to access the data. Then we revamped our way of approaching this data science into pipelines and separating out modularity codes by different scripts. We understood how we need to schedule your pipelines, run your pipelines, and go for that. And your learning does not end with this bootcamp. How you can keep on still learning? I guess the bootcamp link, I'll again, this one. How do we test this model? Are we testing and seeing some practical scenarios? So, how are you going to test? So, if it's an automated machine learning, you can upload a test data set and you can test it and see. Uh, that's how you validate your machine learning models. Yep. So yeah, you can figure out the GitHub. We can go to the GitHub again. That's where we have the entire stuff. Do register if you haven't signed up for a meetup. And live streams and this recordings is already available. You can come back and visit this recordings anytime. Even if you have missed it, you can come and watch the recording sessions. Uh, and yeah, Srinivas, yeah, you can. We are making on credit card application, right? See, Karthik, it's just an example that we brought out. So the whole scenario here is that whether you predict the person is going to do the next payment or not. If you have a different use case, then you can work on that. So let's come back to that a little bit in a little while. I'm going to explain the same. Do follow our handles, social media handles, so that you can keep posted about what events are happening and when it is happening. And if you have not filled your attendance, do fill it right away. I'm pasting it again on the chat. Only on basis of the attendance today, we'll be able to do it. And I'll be closing the form as soon as this live stream ends. So please fill it before that. And social media badge, people who have been posting in social media tagging us, we are noting it down. We'll make a cumulative winners announcement in our group through mailers and in our group channels as well, in our social media and group channel. So feel you have to follow our social media to get to know who's the winners. Probably it might be you. Yeah, reminder for DP100. So yeah, now let's just go and see what's the DP100 course looks like so that we could understand How much of DP100 course that we finished off in 3 hours? So DP100 is where you design and implement a data science solution. The ways how you do it, explore the machine learning workspace, we are done. Working with the data, we are done. Automated the machine learning, we have done. Training the models with scripts, we have done. There's optimizing the model using pipelines, we are done. And the person who asked for hyperparameter tuning, there is a module for that as well. You can go and explore that hyperparameter tuning, which we didn't cover in today's session. And we also deployed and consumed the model. We have covered 90% of the DP100, this one. So what materials I would require, go and learn this one. If it's a free course, this is a free self-paced course, you can go and do it. And I'm also going to curate and send you a special learning path for you to easily become a beginner level data scientist. So which I'll be sharing it right away. And social media, please do tag us. We'll make a social media announcement very soon about the winners. And those who are taking notes, we have noticed, we have also noted down who is the winner for the day one. Hey, can you share the link so we can bookmark it? Yeah, Adesh, I'm sharing the link. Just go to this GitHub repo, which I already pasted here in the chat. This is my GitHub repo, so do give a follow for my profile. Give a star to this repo so that people will get to know that it's this one. Fork and use it as you know, and keep it starred. And I already see people have forked it. Keep the open source mindset and feel free to do whatever you want. So winners, and let's head out a quiz right now. We have the day one quiz winners already in us. We'll reach out to them. We have already have their email addresses. But day two, we'll right away go to the quiz, and the winners will be reach out to the winners. And before going to the quiz, I wanted to emphasize on the two new announcements or the biggest badges that you could get. The one is Capstone Project Champion. So I'm going to walk you through the submission rules for this. So it's completely optional. If you complete and send us, it will be evaluated. If not, it's not. The person who completes this capstone project and completes all the criteria and submission will receive a capstone champion badge. So what is this capstone project is about is that just fork our existing repo. Okay. And then what you have to do is genuinely go and execute this notebook in your Azure ML machine learning workspace and compute. Please take care of your own expenses. It should be under the fee cost. And then instead of using the credit data set, use a different data set and apply a couple of more machine learning techniques. For example, data preparation was not done today. I would expect you to do a little bit of data preparation. Just go and edit the relevant code where you could, replace the data set, add more machine learning techniques, and deploy it. Okay. And once your notebook is ready, you have to upload that to your GitHub repo and also add screenshots of the Azure Machine Learning Workspace where you have executed it. Okay. For example, if you have run a job, I want a screenshot of the job. It should match the experiment name that you have included in your script should match with the same job screenshot that you have attended. So I'm also adding that. So running the notebook, you should add your screenshots in your GitHub repo. So how you need to submit it? Just like me, go to GitHub. Okay, create a separate repository for this. Okay, some sample submission. I'm just going to help you for Azure ML. Just create a repository and then add your code. Okay, upload your notebook which you made, and here, if possible, in the README itself, append all your screenshots here, or you could upload that as a files as well. So here also just create a folder and upload screenshots, or you can upload in README file. And you have to share this GitHub repo link in the submission. Where did that go? Where is it? Okay, I'll just go back to the GitHub link again. Oh, I got 99 followers. So anyone who hasn't still followed, make it 100. That'd be great. So the submission, how you have to do it. Now you know you need to execute this notebook in your Azure machine learning. We want screenshots of that as well, and use a different data set. Don't use a credit again. Okay, that's the main criteria. And then what you have to do, just paste the repo link here. So we'll only evaluate this GitHub repo, the notebook, along with the screenshots. And your notebook should consist of a different data set. You should have used a different data set. And also try to add more machine learning steps to it if necessary. Okay. It's only the organization's decision about how you completed the work, and based on that, we'll grant you the champion badge. So this badge, you can append it to your resume, and you can also append it to your LinkedIn profiles. You can share it across LinkedIn. You can include to your LinkedIn certification badges as well. So if you go here to your LinkedIn, you can add your certifications and links over here. So courses and certification, you can add your link. That link will have a URL as well, so you can append and add it to your LinkedIn profile. Cool. So coming back to this, the next one is Shanmugaraj. You also asked for this the repo. Where is it? Okay. So the next one is called Microsoft Learn Collection Champion. So we give out a badge for this. So how you need to do is that go to the submission. We have created a Learn module. The link is here. It's in the form itself. Just go to the link, and this link will show you the steps that you need to. It has almost the same modules that we covered for DP100. So go to each this one and complete the whole workflows and everything, and then like all your modules. Once you complete the everything, okay. Once you complete everything on this part, uh, what you have to do is go to your profile. Just click on this profile and just share your link of your Microsoft Learn profile. That's it. That's more than enough. We have asked your email, we asked your full name. Just go to your link after completing it. Just go to your this one and profile and just paste your link over here, and that should do the submission thing. Okay, so we will evaluate who have completed this. Yeah, thanks, Karthik. So I think we hit 100 followers in GitHub. Thanks for that. So the persons who have submitted it will be able to get the badges. So the submission deadlines for both Capstone and Microsoft Learn is August 15. So finish it up before it. You have 2 weeks to complete it, 2 weekends. So feel free to do it. And you have a long weekend coming up in after August 12. So you can make use of that. Sorry. So now let's head to the quiz. So we have to complete that course over there in MS Learn. Yes, you have to complete the course in MS Learn and then paste your Microsoft Learn profile link for the submission. That should do. For the Capstone project, you need to take the notebook, use a different data set, add more machine learning stuff, take screenshots of your executions of whatever you have done, and then add it to your GitHub repo and share the GitHub repo with this. So that's a Capstone project's criteria. So now let's head to the quiz. So quiz link is up in the chats. Or you could scan this particular link as well. So I'll bring the link over here. So it's going to be 7 questions. So I'm bringing the link to the screen. So just hold on for that. So yeah, join in, scan the QR code or click the link in the chat to join the quiz. Yep, we have folks coming in. So it's only going to be a very simple 7 questions, very straightforward questions. If you just listen to whatever I said, even if you listen to the end of the session where I summarize, you will be able to finish off the quiz with maximum. So correct answers with maximum points, do it. Don't switch tabs while you're using quiz. That means you will lose a question because you won't be once you come back, you won't be able to see the question. Don't refresh your app or don't refresh your browser. Just keep on the same screen and your questions will appear on the screen. So we'll be starting in 2 minutes. Once we reach the count of 30, we have 21 folks over here. We have 31 folks watching in live stream. So once 30 people have joined or 25 plus folks have joined, we'll start the quiz. Those who does not want to join the quiz, you just want to take part, awesome, Adish. I'm looking forward. So if you have any doubts to do reach out to me. That's the whole point of learning here. So it's not that we are evaluating you, we are helping you out to accomplish your own project. So reach out to me if you have any doubts. I'll help you out in the Capstone project also for necessary. And for college students, this is an amazing way you can explicitly tell that you have done a Capstone project in Azure Machine Learning with the badge which is awarded to you. It holds a very good reputation in your resume, which you can use in your interviews. It will also help you to appear for DP100 Data Scientist Associate certification with confidence. So take use of this opportunity. I think we have reached the numbers, so I'm going to start the quiz. Once again, people, before I start, keep a look at your own application. Don't switch tabs. Don't refresh. Don't. It's not necessary for you to come and look at the live stream. Just stick to your app. So I'll just give for a moment for you to go and switch your tabs for your app for your quiz, and let's start. I'm starting in 5, 4, 3, 2, 1. Your live stream will be a little bit delayed, so stick to your application. The scoring script loads a trained model to predict the label of the new input data, which is also called, what is a scoring script where we do the prediction part? It's called. Yes, it's called inferencing. So where you make the prediction with a scoring script. So 38 folks, 10 folks got it right. Which is not a type of online endpoints. Managed online endpoints, custom compute online endpoints, Kubernetes online endpoint, local endpoint. I would rephrase, it's about which is not a type of the endpoints which is available. So I would say the custom compute is also an endpoint. So yeah, most of the folks got it right. Kubernetes is still an endpoint. We saw that, right? So Kubernetes and managed online endpoints. So most of the folks got it correct. So thanks. What is called registered model? What is a registered model called in Azure Workspace? Is a model asset, scoring script, environment, compute config. Pretty easy, pretty straightforward. Yep, most of them got it correct. So I don't know why folks go for scoring, environment, and compute. Please pay attention to the question. It was pretty straightforward. If you register a model, it's called a model asset. What is an independently executable workflow of a complete machine learning task in a machine learning in Azure machine learning? The answer is evident. It's a pipeline, data explorer, components, or job. It's The answer is pipeline. Yeah. Uh, Folks are being dropping out, I guess. So who is in the leaderboard right now? We have Rahul scoring 4 out of 4. Ahmed, Arun Neelakandan, Anisha are topping the top 5, and Vignesh. So next question coming right away. Which is not an advantage of Azure machine learning pipeline? Heterogeneous compute, which means different compute for different steps, reusability, tracking and versioning, no collaboration. I think it's very evident. I wanted to keep the quiz as simple as possible. Yeah, the aspect is that you can actually collaborate, and heterogeneous compute is where I told you, right? So for each and every step, you can assign different compute for each step. And reusability, you can share, you can reuse the same steps for different pipelines as well. It's not necessary that one step is allocated to one pipeline. You can reuse a step in different pipelines. Next question coming up right away. An unit of execution in pipeline is called step, job, script, compute. A unit of execution in pipeline. It's particularly in pipeline call. I'm expecting a little bit of turnaround here. Yeah, I expected this particular response. I'll give you the reason why the question was formed. A unit of execution is called a step, but once you execute it, it's called a job. Okay, so in a pipeline, one thing which can be executed is called a step, but once it's executed, it becomes a job. Okay, so it's a step. I think that serves the explanation. How to run pipeline on recurring basis. We didn't see the code of it, but we saw the this one. Repeat mode, schedule reoccurrence, rerun mode, cron job. So Arun topping the leaderboard right now, but let's see how it turns out to be. And Anisha dropped to sixth. Anisha, keep up and try to bring to the top four. Yep, amazing. So Rahul, Arun Neelakandan, and Srinivas are fighting for the top three. I'm still amazed with how Srinivas is able to keep up because he joined a little bit late, but he has domain knowledge, I guess. Schedule reoccurrence. So cron job is also correct. If people can oppose me or contradict me, cron job is also correct. But on a machine learning and Azure machine learning space, cron job you can write your own cron jobs, but schedule reoccurrence makes it much more easy for you. That's a right straight away answer. Anisha jump to the top five, into the top five. So last question. Automating the workflows of machine learning is called simple. Let's make it strong. Who answers it first? Let's see. AutoML, Azure machine learning, model monitoring, and so on. So it's AutoML. Yep. Azure machine learning is way to streamline your pipelines. It's not to automate it completely. Automating your machine learning workflows is AutoML. Let's see who is the winner of this quiz. Srinivas, amazing. So you came in late and you still made it to the top. Congratulations. Anisha was flickering behind from top three to top five to top seven. Still, somehow managed to take it to the top with just 79 seconds. It's pretty fast that you answered all your questions. And I'm not sure who's 54. We'll reach out to the person. So the top five, please reach out to me. Uh, And David, congratulations, David, and congratulations, Ahmed. And Rahul, you just missed in just 1 second gap between Ahmed and you. Congratulations. And Arun was stopping us through the entire time, somehow slipped. And there was a tough competition between Ahmed, Rahul, and Arun Neelakandan. But for the spirit of the quiz, what our plan right now is that we'll award all the 10 folks from quiz 2 because you have been attentive throughout the entire session and you have come. So only for the quiz 2, we'll give the top 10 people, all for the top 10, we'll give the badges. But congratulations, everyone. So congrats, David, Rahul, Arun Neelakandan, Krishnan, Ashish, and Harish. So congrats to the top 10. We'll give top 10 batches for the quiz, day two quiz, because you folks have been listening from the beginning. I have been actively seeing that. So for the spirit of everyone, I'm giving it for top 10. So what's next? We are at the end of this bootcamp. So you have the link of this GitHub repo, or you can find me in GitHub. I'll again make a post. So, and regarding the participation certificate batch, as well as the winner batches for social media and your quiz, we'll announce the winners in our WhatsApp group, in our social media handles as well. So if you want to join our WhatsApp group for discussions and everything, you can join our WhatsApp group over here. I'm pasting the link to it. Just give me a second. So we will announce it on all our social media handles. So please follow our social media handles for the results. And Sandeep, okay, you are Sandeep Chakravarti, Sandeep 54. Okay, so winners of today's event for the quiz especially, reach out to me in DMs with your email addresses. Either it can be LinkedIn or it can be Twitter, anywhere else. Or just ping me in my Twitter or LinkedIn that what is your email address so that we could uh, send you the batches. Batches will be sent directly to your email addresses, and there is a way how you could capture it. So it's pretty straightforward. And congratulations all, and thank you so much for being part of this bootcamp. We have made a tremendous impact with this bootcamp. So please take some time to fill the feedback or your attendance form. Your feedback will help us to understand how you felt throughout this bootcamp and what do you want to learn next. So, and folks, if you like this bootcamp, so a lot of efforts have been went through to organize all the learnings and to formulate as a notebook and everything. We have made it completely free of access. The best you could do is give us some credit while you use it, or if you felt this bootcamp made some impact, do share a word in your social medias, do target. That's how it's not just for my own satisfaction, but it's more that people will get to know such and such events are happening in our community and they'll be getting benefited in the future. So it's only for the community benefit. Please share this in your social medias. Please tell us how you felt it. And before we conclude, I think Rahul brought up a question. So how is LLM model deployment different from traditional model? As LLM is already deployed and we use a model as an API, could you share that what is the difference in the deployment strategy? Okay, good question. So before we go, we'll touch base a little bit on the generative AI. And you guys are interested in generative AI, we'll talk about it in upcoming session. So Rahul, answer to your question. See, LLM models have been already, it's nothing but it's as same as your traditional model deployment. But we need to take care of your scalability and accessibility because of your large, it's a huge chunk of model. You need to make it inference as fast as possible. So only on the aspects of scaling and your way of deployment, it's a little bit different. But otherwise, it is exactly same as deployment and traditional. Yeah, Sandeep, I noticed that you are Sandeep 54. Just reach out to me in LinkedIn. You have the links, everything in this one, and so that you could do it. Anisha, thanks for your feedback. And please do make a post if you log this bootcamp. Thank you so much. And coming back to your answer, so yeah, LLM is already deployed by some organization. For example, your LLM of your chat GPT 3.5, GPT 4 was deployed by uh, OpenAI. So they have done it from their end. We are just using it as an API as a code. And we okay, as LLM is already deployed, we use the model as an API and a code. Could you share the difference in deployment strategy? So the only deployment strategy difference is that it's entirely the same, but the way how you deploy it, since it's a large model, it's a huge model, the running time, inference time might take some lot of time. So you try to establish a lot of clusters or compute power for it to easily process it. And before you send a request, it's not be just an API. You try to make sure that the APIs are reaching faster. So you use API services like API management servers in Azure so that your APIs are hit always. There's no, you try to have a load balancers before you hit the service so that you never miss a request. So these are some deployment strategies they include while deploying huge models. Even in my organization, in my product, we have deployed a huge model, and we have used this strategy to make sure that the model is able to serve under a second for your inferences. And thank you for your feedback. I'm really thank you that okay, just to know how much ChatGPT will be used for ML. So it's a companion. So it's a machine learning outcome or use case. You could use it for various applications for text generation and so on. So it is entirely useful. Thanks for your amazing this one. So I'm going to close the bootcamp as soon as the live ends. So please fill it up, give some honest feedback so that we could improve and we could serve you better in the future. And thank you so much for taking some time yesterday evening, Saturday evening, and Sunday morning to learn something new. I hope so. It helps you to accelerate your data science career. And you know about the Capstone and projects. So if you have any doubts, do reach out. And quiz contest, we have already had it. So how to connect with me? So I am available in these and these links. The links is already available in the GitHub repo, and I'm available in all LinkedIn, Twitter, and GitHub. So thank you so much. Thank you, Azure enthusiasts. I'm looking forward to meet you all in some in-person event or in next virtual event. We'll talk about more about Azure machine learning or any service that you want to learn. So until then, have a good weekend and take care and goodbye.